I can express metric capacity measurements in terms of a smaller unit, model and solve addition and subtraction word problems involving metric capacity. Today, you're going to learn about metric capacity. Yesterday, you learned about metric mass. The day before, you learned about metric length. Today, we're talking about capacity. Okay, let's just review a little bit. Just a reminder, 1 meter equals 100 centimeters. 1 gram equals 100 centigrams. See how that works? 1 kilometer equals 1,000 meters. 1 kilogram equals 1,000 grams. So I have 2 kilometers. I pull 1 kilometer out, and I want to say how many meters I have left. How many meters are in 1 kilometer? Go ahead, solve it, and then move on when you're ready. So, there's 1,000 meters in 1 kilometer. So 1 kilometer plus 1,000 meters equals 2 kilometers. Because 1,000 meters is the same as 1 kilometer. Okay, 560 centimeters plus 230 centimeters. I can't remember how to solve this. Can you do it for me? First of all, think about meters. I'm going to go ahead and help you out just a little with this one. And I'm going to underline the meters. So we have 5 meters. How many centimeters are left in 560? And 2 meters. How many are left in 230? Go ahead and finish the rest on your own. Pretty easy stuff, I would say. Okay, let's look at the next one. Can you solve this one? Once again, you're going to look at your hundreds place to see how many meters are in each number. You might be able to do this one in your head even. Looks fairly easy. Just make sure you put the numbers in the right blanks. Okay, pause and move on when you're ready.
Welcome to Metric Measurement, Episode 2, about capacity. Have you ever noticed the number 236 followed by a little m and a big L on your milk container? These numbers tell you the capacity of your milk carton. Capacity is how much liquid something can hold or how much space is inside a container. In this podcast, you will learn how to identify and describe the size of a liter and a milliliter. This can help you to estimate capacity quickly and correctly. Here in the United States, we measure capacity with customary units like teaspoons, cups, pints, quarts, and gallons. However, scientists and most other places in the world use metric units of capacity like the liter and milliliter. A large water bottle like this holds 1 liter of liquid. The most common place you might see liters is when you buy a large bottle of soda, like this. A bottle this size holds 2 liters of soda. If you divided the space inside a liter into 1,000 smaller spaces, you would get the size of a milliliter. So, 1,000 milliliters equals 1 liter. A milliliter is the amount of water this pipette holds up to the 1 milliliter line. 1 milliliter is about this much water. This graduated cylinder also measures milliliters. A milliliter is a very small unit of capacity. It is useful for measuring things like this cough medicine, or how much water you need to give a cactus each week. Now that you know a little bit about the size of a liter and a milliliter, it is time to use what you know. Here is an example. Check out this cooler. Would you like to use liters or milliliters to measure its capacity? Usually, when you measure something this size, and you don't need to be exact, you want to use something that would fill it up quickly. Since liters are bigger than milliliters, liters would be the best choice. Next, consider this eyedropper for medicine. This is small, and you want to be exact with your measurement. A liter is too big to measure the space inside the eyedropper. The best units to use in this example are milliliters. Now you're on your own. Would you use milliliters or liters to measure the capacity of this vanilla bottle? Because of the size, you would use milliliters. Would you use milliliters or liters to measure the capacity of a bathtub? The best choice would be liters because of its large size. What do you think about this bottle of vinegar? It may look like you could use liters, but it is still too small. You would need to use milliliters. Now you can use what you know to estimate the capacity of things around you. Look for containers that hold liquid and guess which unit was used to measure what it holds. Remember that liters are a bigger measurement when compared to milliliters. If you forget, imagine this 1 liter water bottle holds 1,000 milliliters. Stay tuned for the final episode of Metric Measurement, where we will be exploring units of weight. Until then, happy metric measuring!
Okay. Right now my beaker has 800 milliliters. How many more milliliters do I need to make a liter? So I have 800. I'm going to draw a line for the 1,000 because if I have milliliters, did you know that 1,000 milliliters equal 1 liter? How many more? I have 800. How many more milliliters do I need to make a liter? Go ahead and write the answer on the slide. One liter is the same as 1,000 milliliters. Okay, color the beaker to the 1,500 milliliter line. Now, how many liters do you have? Okay, pause, continue when you're ready. I have 1 liter, 500 milliliters. I was only 500 away from 2 liters. Okay, look at this cup. How many liters does it have? 1 liter. How many milliliters? You're going to look at the 1,600 number. So go ahead and fill in the blank. Look at this next beaker. It looks like it's a little over the line, but it's about 4,500 milliliters. Right, how many liters I have, and then how many milliliters are left. Okay, let's look at this one. I have 3,500 milliliters. How many liters do I have? How many milliliters do I have left? Can you solve the following problem? You may use a simplifying strategy or algorithm. Now remember, there's 1,000 milliliters in 1 liter. Okay, so that will help you because you'll either say 32 liters, 420 milliliters plus 13 liters, 585 milliliters. Or you'll solve it by saying 32,420 milliliters plus 13,585 milliliters. Okay, solve it the way you choose, whichever way is easiest for you. Okay, so go ahead and pause it. Once you're done, we will continue. Okay, check it out. How did you do? Your answer should have been 46 liters, 5 milliliters. Now, I showed you an example of both strategy and algorithm. So if you choose, or simplify. So if you choose to simplify, or if you choose to solve the algorithm method, you will get the same answer both times. So look at what we did here. Look at how you solved it. If you got it wrong, you need to pause and you need to look and see what you did wrong, okay? It's so important. Just one more hugely important thing. If you make an error, you need to care enough about your mistakes that you're going to go back and you're going to look at them and see what you did wrong so you don't make the same mistake twice. Okay, that's how you show you care about your work. Okay, let's look at the next slide. Can you solve the following problem? You may use a simplifying strategy or algorithm. So, go ahead, pause it. Just remember, 1,000 milliliters is the same as 1 liter. So you could say 12,215 milliliters minus 8,600 milliliters, or you keep them the same and subtract. Your choice. Pause it, solve it, move on when you're ready. Okay, your answer should be 3 liters, 615 milliliters. Look at my answers. Look at your answers. Look how you solved it. Did you do it correctly? Did you do it incorrectly? If you did it incorrectly, it's your job to look and see what you did wrong, okay? So look at that now and see what you did wrong. If you got it right, good job. You know exactly what you're doing. Okay, Jennifer is making 2,170 milliliters of her favorite drink that combines iced tea and lemonade. If she puts in 1 liter, 300 milliliters of iced tea, how much lemonade does she need? So, you're going to highlight important information, draw a tape diagram, and solve. Pause the slide, do those 3 steps now, and then we will proceed and you can see the answer and how it was solved. Okay, the important information that's been highlighted is 2,170 milliliters of her favorite drink. She puts in 1 liter, 300 milliliters of iced tea. How much lemonade does she need? So we know that in all we have 2,170 milliliters. She's already used up 1 liter, 300 milliliters. What's another way to say 1 liter, 300 milliliters? What's another way to say that? We could say she's already used up 1,300 milliliters. So how much space is left for her to put her lemonade? Because we're talking about capacity. So far, we have filled up 1,300 milliliters of a pot that only holds 2,170 milliliters. how much room is left to add the lemonade? So, let's look at this. How much space is left? How much lemonade does she need to fill this pot or this pitcher? So we're going to take 2,170 milliliters minus 1,300, because I've already used up 1,300 milliliters of that space. That's why I have to subtract, because I've used it up. I don't have that amount left, and then this is going to tell me what I have left. It's going to tell me the difference. That's the answer you get when you subtract. So I have 0 minus 0 is 0. 7 minus 0 is 7. 1 minus 3, can't do that, so I got to borrow from the neighbor. I borrowed 1 from the neighbor. The one I just borrowed goes in front of the neighbor. So 11 minus 3 is 8. And then 1 minus 1 is 0. So Jennifer needs 870 milliliters of lemonade. If she does 871, I have a feeling it might spill over the top. And then she might not be very happy. So, in this case, you wouldn't want an estimate. You wouldn't want to assess if it's a reasonable answer. You want the exact answer. When you're dealing with capacity, you have to have the exact answer. Okay? This problem set looks a lot like your previous problem sets. Let's look at number 2A. 2 liters, 500 milliliters is the same as, well, remember 2 liters is the same as 2,000 milliliters. 500. So 2 liters, 500 milliliters is the same as 2,500 milliliters. Now, on 3B, I have 7 liters minus 3,400 milliliters. Well, I'm subtracting 2 different units. I could set them up the way I set them up yesterday, or I could just start by saying 7,000 milliliters minus 3,400 milliliters. Okay, and on D, C and D, it says express the answer in the smaller unit. The smaller unit would be